Today I'm going to speak to you about the electrical transformer as shown here. This is what you were taught it has to look like. In other words, it has to have a core, and that core is meant to couple the flux from the primary to the secondary. And in reality it looks something like this. You've got your core made out of soft iron or ferrite or whatever to create the coupling. But you don't need this core. I'm going to show you this design has been known and working since the early 1980s. The green coil I'm showing here is the primary winding, and around it is one turn of the secondary. It's basically a, in this case, copper or aluminium, and the idea is it's just one turn. All the flux from the primary winding has to go through the secondary. If I take a slice through one of those inner conductors, I could explain the flux in the following manner. As each cycle sort of gives off its pulse, that entire pulse has to go through the secondary, because the secondary now encapsulates the inner conductor. So in that way you don't lose any flux. The only area of loss is here where the opening is. I've drawn it quite big here, but you can understand if you make this larger that this gap can occupy less than 1% of the total circumference. And that means that this transformer can therefore be 99% or more efficient. And that's because, as I said earlier, all the flux from the primary will be collected by the secondary. It cannot escape. And it doesn't have to be tightly connected or wrapped around the primary. There can be a gap. It will still pick it up. This does work. I have tried it. In fact, I tried it back in the early 1980s. I was going to build an arc welder. The only consideration you have to have is that your frequency which you are putting into the primary has to be high enough so that the impedance works out to be what you want. In other words, if you try and connect this up to your mains, it's probably just going to blow, because at 50 or 60 hertz the impedance will be way too low. So you're going to need some kind of electronic switching circuit to raise the input frequencies to the point where the impedance will draw the current that you want.